Alberta.
Thank you, Rob. Good afternoon. My name is Longfu. I'm with AEMERA. Today, Daniel and I will do the presentation on high-resolution air mapping tool for oil sands region for Alberta. I will do the introduction, and Daniel will do the heavy lifting and hopefully answer all the technical questions. But if there's any questions related to the implementation and the deployment of the tool, that I will answer them. Recently, in searching for a romantic dinner topic, I need to know all the prime numbers below 100. And to do that, a computer called Wolfram Alpha will give you definitive answers to the kind of scientific questions like this. And here's the answer, and all the prime numbers below 100, those ones in bracket, they are called prime twins. And for those people, your loved one's age and your age are 2 years apart, you may want to take note. But of course, you can also Google on the same subject, and then you will get all kinds of questions, may not be definitive to your definitive answer, but they will also give you the context. So the message I got from this Google result is that I should have been more ambitious and optimistic because there are prime twins beyond 100. And here, this is often the case for when we do environmental monitoring. The animation is half step too fast. But if you look at the picture on your right-hand side, that's the fixed underground station monitoring network in Alberta. And those stations will give you definitive answers of the air quality parameter at this those exact location. But if you take a satellite image, it will give you a bigger picture, but the concentration is cumulated vertically over the entire region, so that you may know the bigger picture, the context over the province, but may not be the definitive answer that what you're looking for. But you know, from the keynote speaker, Dr. Hansen, this morning, that human brain is part of the monitoring program that really resonates with me. And also, if we want to be ambitious and optimistic, we combined both the information from both methods, and we'll have a new computer model that gives us more insight and more detailed information about ambient air quality, cover the whole province. So that is the design concept of this new approach, air mapping tool, which Daniel will present this application for the oil sands region.
Thank you, Long, for this original introduction. So, I will start with the presentation and demonstration of the tool. Before that, I should mention and make you attend again on, there is a very simplified version of this application, which is owned by AEMERA. So this application is simplified in a mobile web application. That means you can, if you click on this or if you connect to this link, you can display some of the information on your mobile devices. One warning, it's a mobile web application, so if you open it on your laptops or desktops, it wouldn't look nice. Anyhow, also, there is an excellent demonstration of this tool in the room 19, already for the second day. There's still an opportunity to talk with specialists from AEMERA who can manipulate and operate this application with the graphical user interfaces and sub-applications. Why do we develop, why do we need environmental mapping? Actually, it has been mentioned already during couple of presentations, including the keynote this morning. We need synoptic information. If we want to estimate the impacts of environmental pollution, whether environmental effects or population health effects, we need information in synoptic formats. That means we have to be able to combine the air pollutant, in this case air pollution information, with other information, also in mapping formats, such as the demography, population densities, location of the vulnerable objects, such as schools, sport fields, and only combination of these two sources, synoptic sources of information, can provide you answers in what are the effects, the impacts of air pollution. Of course, it must be timely and up-to-date. Not only historical data are of importance, but also real-time or near real-time data need to be collected and interpreted. Also, this has been stressed a couple of times during today, I believe, and even yesterday presentations. And needless to mention, we have to know what's the accuracy of the monitoring or of the mapping. Now we know why we do it. How do we do it? How do we develop the monitoring results in mapping formats? In principle, we use various sources of information and various sources of data. In the first place, I should have mentioned it's the monitoring networks. We, specifically for the oil sands area, we are hourly downloading the WBEA measurements online and introduce them in our models. As a second source of important information, that's the satellite Earth observations. For that, we download data, obviously not hourly, but daily or even weekly, from various satellites. AEMERA, it has been mentioned in the Environment Canada presentation. There is also a poster about the AEMERA instrument. EARS, and NASA, and MODIS, another NASA satellite instrument. There's a new mission planned, which will be launched less than a year from now, and that will provide us superior information, superior data with improved spectral and spatial resolution. So maybe next year in presentation, the Earth observation inputs will be rightly on the first place. Of course, we need weather information for the dispersion modeling. We need geospatial information because we have to interpolate and extrapolate the data which are collected at points into maps. And of course, we need also some forecasting modeling if we want to know what's happening 24 hours from now. Which pollutants we are able to map by using the Earth observation technologies. First of all, nitrogen dioxide, one of the major air pollutant responsible for health impacts, PM, aerosols, another one, ozone, carbon dioxide, sulfur dioxide, and also GHGs. Okay, I guess now is the time that I switch to the application. I hope it will work. It worked a few minutes ago, so it should work still. Yes. Okay, I found it. Right. So this is the first major user interface which opens the application. What can we show? What can we see? First of all, this is a map. In this case, a map of distribution of PM2.5 across the area of oil sands. Each color, it's color-coded. The concentrations are obviously color-coded. Each color refers to a specific concentration of PM2.5. Now, this application has many sub-applications and many features. I will go through them. Let me see how much time I have. Enough yet. There is a taskbar with standard functionality like saving the data and saving images, deleting the history, and saving also the gridded data. View refers to several sub-applications. I will refer to them in the course of my presentation. We can select sites, specific sites on the map, where we want to retrieve the information right on the spot. We can deselect them again. And then the standard GIS manipulation functionality like zoom in, zoom out, returning to the original format, panning, and cursor. On the left-hand side, we can select which regions we would like to map or to display and manipulate. Since we are dealing, in this symposium, we are dealing with oil sands, we will stick with the oil sands region. We can select the resolution, varying somewhere between 10 kilometers and 2 kilometers. 2 kilometers is about the finest resolution which we can achieve with the present satellite sensors. We can select the air pollutant or even AQHI and elevation for mapping, for displaying. Let's see, PM 2.5. Now, what we want to see could be also shown or even statistically processed. We can see the maximum, display the maximums, averages, minimums, percentiles, exceedances. All these statistical functions are defined by the user, by the customer, in our case, AEMERA. We have also a possibility for animation, which means when selecting a time period, we can run all the imagery step by step. This is for the selection of the time period. We can select the percentile levels and exceedance levels for the manipulations. On the right-hand side, we can choose which map layers, GIS layers, we want to overlay over the concentration maps, roads, water, just to give you an idea. Interesting is we have also the monitoring stations layer, which shows the sites, the monitoring, the WBA sites, and we have also information about the emission sources, which are displayed in this case. Interesting is we can follow the coordinate values and the pollutant values in these windows on the right-hand side. And upon request of our customers, we can also change the coloring, the color of the scales, and of course the range. So this is the first basic screen of the application. We can show the data in time series. Oh, I have already prepared it. So this is a time series for the selected period of time. It's actually the month of December, showing the values as detected at the stations, WBA stations in oil sands. It has also some edit functionality for saving, and the graphs could be smoothed or not smoothed. So all this functionality is actually defined by the user, by the requirements of, in this case, of AEMERA, which we introduced in the product. Another sub-application. Is possibility of reviewing and downloading data, CASA data, or any other source of the information. There is an algorithm, there is a model which allows estimates of oil sand emission, of the emission rates. The emission rates it's the total emission, not, meaning the natural and anthropogenic. We still are struggling how to develop a technology for separating these two sources of emissions. I will show you an image or a picture, a time series. Let me see. It was, during one of the previous presentations, it was mentioned there was an event, maybe a forest fire on 5th of August last year. Obviously, it directly led to increase of the emission rates. By the way, this is an integrated emissions over the whole area of oil sands. Once we have the new satellite sensors, we'll be able to specify the locations of the emission sources, and this will permit us also differentiation between the anthropogenic and natural sources of emissions. Yeah, I'm almost done. We can display, oh, that was wrong, I shouldn't have done that. Maybe I still, okay. I shouldn't have clicked on the, because this will, okay, I can go back, that's good. Yes, this is the one which I wanted to show you. This is the real-time or near real-time data display and manipulation interface. We have started the collection of the data this morning, and this slide displays the NO2 concentration at 2 o'clock in the afternoon. We can view it also in time series, and the time series has let me see. Yeah, that's the right one. It shows the real-time data collected today, but it also displays the forecasted concentrations for which we have developed a specific model. This is something new. It's still under development and will be delivered, provided to AEMERA within a couple of weeks. So, yeah, I guess I'm slide.
Okay, fantastic. All right, thank you very much. Question or two, the website, where do you go to get it? Was that to get the application? That was just at the very beginning?
Yeah, that's also on, I'll go back.
You want, just in case anybody wanted to write that down, if you were looking for that application, the website is, there we go. Nope, too far back, I think. Down a couple, there we go, perfect. So if anybody wants to jot that down, they can get it. There is a demonstration. I think, will you guys stay around for a little, like for another hour or so in room 19 there? Okay, so they're still in room 19. If you actually want to see it, work your way through it, press some of the buttons, see how that goes, then by all means, get over there, and then they'll stay for a bit and show you through that. Okay, any specific questions then outside of probably just wanting to play with it and use it? Okay, good enough. Thank you very much.